Okay, so now we're going to be talking about resistors in a circuit. So right now we're going to be talking about series. So resistors in series means that we're going to have a battery, and it's going to, let's say it's going to be 13 volts. Let's do 13 volts. And we have one resistor right here. We're going to call this R1, or R1. And it's going to be 3 ohms. And then we have one right here, and that's going to be R2, and that's going to be 4 ohms. And then we're going to have one right here, and this is going to be resistor 3, and we're going to make that 2 ohms. And then we're going to have one more resistor. We're going to make this R4, and R4 is going to be 5 volts. Let's go with, or 5 ohms. So we now have resistor 1 with 3 ohms, resistor 2 with 4 ohms, resistor 3 with 2 ohms, and then resistor 4 with 5 ohms in a 13 volt battery. So in order to calculate the resistors in series, we just basically, to calculate the total resistance, we just add all the resistances together. So the formula would be RT equals R1 plus R2 plus R3, and so on and so forth. So for this, we're going to go 3 ohms plus 4 ohms plus 2 ohms plus 5 ohms. And that gives us a grand total of 14 ohms. So we now have a 13 volt battery, and it's now its total resistance. So we're going to draw it. So it's going to go like this. And its total resistance is 14 ohms. So now that we have the total resistance, we can calculate the potential difference, or potential across the current through each resistor. So basically, when you have in a battery itself, it has a voltage, which is going to be the change in volts, equals the current, which is going to be the total current, times resistance. So in order to find the current through each of these, basically in series, everything is going to have the same current because it all flows through, and there's no breaking point, nothing stops, it all flows evenly through each and every resistor. So it's going to be 13 volts over 14 ohms. And that is going to give us, let me grab my calculator real quick. That's going to give us 0.93, oops, 0.93, and current is always measured in amplitude. So 0.93 amps is the total current through this whole circuit. So now, since we have that, we can figure out the potential across each resistance, and it's every resistor is actually going to receive 13 volts. So there's going to be no potential drop or voltage drop, because they all receive the same amount of voltage because they're all in series. So for this, we now figured out that the grand total of resistance is equal to 14 ohms, and that the total current is 0.93 amps, and that is all calculated through the one formula that you always need to use, which is going to be the voltage, or the change in voltage, equals the current times the resistance.